Okay, so let's find the equation of the line tangent to y equals f of x equals x squared. Excuse me, if x equals 3/2. Okay. First of all, if x equals 3/4, y equals f of x equals 3/4 squared, which is 9/16. Okay, now just to get a handle on 9/16, because you're probably frightened to death of fractions. Actually, you might well not be, but for some people this is kind of frightening, because you've had a calculator in your hand since you were 6 years old and never really learned much about fractions, if you're typical. Okay, now this course is aimed at pretty smart people, so you're going to be much better than that. But let's just review. 9/16 is close to what fraction? Well, it's pretty close to 8/16, which would be 1/2. It's a little more than 1/2. Now you could do a decimal equivalent, and that's perfectly appropriate in some cases, but right now we're doing exact mathematics, and we're not doing decimal equivalents, decimal approximations. Okay, so we're just going to forget about decimal approximations for the moment. Yeah, I mean, that's what, 0.5625, I think. Not necessarily a fraction you would memorize. You ought to know what the decimal equivalent of a lot of fractions are, and that might be one of them. Okay, well, so much for that. We're not going to do decimal equivalents. Okay, x equals 3/4, y then equals 9/16, which tells us what? It tells us that on the graph of this function, and let me just draw a graph to represent y equals x squared, okay? Graph might well look something like that. Curvature might be more like x cubed. Not too concerned about that. Okay, we got the point 3/4, 9/16. Now, actually, 9/16 is kind of close to 3/4. So, if we have equal scale, well, if we were using equal scales here, we'd want to come over to a point here where the y coordinate is just somewhat less than the x coordinate. So let's just pretend we've done that. And this point is at x equals 3/4. And this point is at y equals 9/16. And it looks like I got a little high with the 9/16, but this is just to be understood as a schematic, not an accurate diagram. The point 1,1 would be here, here. It's not a bad graph if you assume we have equal scales. And we don't have to have equal scales. Okay, so ignore my digressions if you possibly can. We know that the point (3/4, 9/16) lies on this graph. Now we know we want to find the equation of a tangent line. What do we need? We need the slope of the graph. Okay, the slope of the tangent line at this point. Okay, so here's your tangent line. What's the slope? Slope is the derivative that I'll denote by f prime of x equals f prime at the x coordinate, f prime at 3/4. So what's f prime at 3/4? Well, f prime of x, the derivative of this thing, which is very easily derived using the difference quotient, and which I assume you've seen, but at least I assume that you know, is 2x. Now, if you don't know that the derivative of x squared is 2x, you need to go back and make sure you understand that before you start trying to do tangent lines, because if you can't take the derivative, you can't do the tangent line. Okay? So, but the derivatives are very simple. Okay, at this stage of the course, you got some rules for derivatives. Takes a little while to get used to, but they're not difficult. They just take practice. Okay, some of them are a little bit difficult, but this is just a straightforward derivative. Okay, so f prime of 3/4 is 2 times 3/4 equals 3/2. Okay? So now what do we know? So if we want to come back to this formula, x1, y1 are what? Well, the point x1, y1 is 3/4, 9/16, and the slope is 3/2. And this gives us our equation of the tangent line is going to be y minus y1. Okay, we'll use this form. So that's y minus what? 9/16 equals slope times x minus x1. Slope is 3/2 of x minus x1, which is x1 being 3/4. Okay? And generally we would solve for y to get the slope-intercept form of the equation. Now the process is always the same. If you're given the value of x at which to find the point on the graph and therefore and then the tangent line, you're going to plug that into the function to get the value of y, and you're going to use that point then, the point that you get, the point x, y, corresponding to that value of x, and then you're going to find the derivative of your function and use that derivative to find the slope at that point. Then you just have a slope-intercept form, and you don't have to memorize some unimaginable formula to do this. Okay, now I'll add just a little bit down here and show you the unimaginable formula and how simple that formula really is, even though it looks a little intimidating because you're not quite used to thinking in terms of all the notation.